This is the second step in our four-step process of legging up the chair. It's an exciting step because when we're done, we're actually going to have a seat standing on four legs. We have to put a stretcher in later on, but the chair from this point on begins to take on form. Before we begin, we need to talk about the chair's joinery. Windsor chairs are put together with what is called socket construction. Socket construction is round hole, round tenon. Why use it? Because it's quick and it's easy to do. You've seen me drill holes in wood. You know how quickly that can be done. A round tenon can be made in a number of ways, very quickly and easily. But socket construction has a dirty little secret. And that secret is that it is the second worst joint known to woodworking. The worst joint in woodworking would be to try and glue wood end grain to end grain. You know the problem there. When you look at wood under magnification, it's a bunch of openings. It's like if you went into a grocery store and took a cardboard box of soda straws from the shelf, opened the box and looked down into the box, you're going to be looking at a whole bunch of holes. That's what you're looking at with wood. If you smeared glue on the holes, on the ends of the soda straws and tried to glue them together, there's not a lot of surface in contact. Whereas on the other hand, if you smear glue on the side of the soda straws, glue them together, you get a good glue bond. That's why this is such a bad joint. And it ties into why this is a bad joint as well. Let me draw you a picture. To illustrate the problem of socket construction, I'm going to draw you some wood. So there's the grain in wood. I'm going to drill a hole into the wood. Now, how much of the inside surface area of this hole is edge grain, which will give you a good glue bond, and how much of it is end grain that will not give you a good glue bond? The only place there's edge grain is on those two tangents. All the rest of this surface is end grain, and if we try to glue it, it won't hold. And you know that it won't from your own experience, because what's the first thing your friends and your neighbors ask when they find out that you're a woodworker? Can you glue my kitchen chairs? Why do they ask it? Because factories insist on trying to use socket construction as an adhesive joint. It won't work. Over time, the glue bond will fail because of what we've just shown you here. There's a lesson for us here. And that is, if we wish to take advantage of the speed and the ease with which socket construction can be made, we cannot rely on glue alone. Every time we make a joint in a Windsor chair, we will incorporate into that joint some mechanical property that will be responsible for holding it after the glue has failed. This is the first one. I'm holding in my hand the dead center from my wood lathe. At first glance, it looks like it's a bar of round stock, but if you look at it carefully, it's actually thicker here than down here. It's a taper, it's a cone. It's actually known as a particular type of taper. It's called the number 2 Morse taper, and it's one of a type of locking taper. If I put this into the tailstock and then try to pull it out, I can't. Why? Because friction sets up in there and locks it in place. Now, most solids will lock at some degree of taper, and the same applies to wood. The top of this leg is tapered. the same as the dead center from the lathe was tapered. I take and put it in a hole that's been reamed to the same shape. When I was a younger man, I could lift the bench top. I guess those days are over. Anyway, the joint has self-locked because of the friction in the joint. Now, if I were to set this joint up, leave, walk away, come back a year later after a heating cycle, a winter and a summer, this joint would most likely be loose because the seasonal movement of this wood has loosened the joint. The great thing about this joint is, while it may not be permanent, it is self-rejuvenating every time somebody sits in the chair. One of the secrets with a Windsor chair is that when you sit in it, you tighten it back up. And this joint here, this locking taper, goes a long way to explaining the longevity and the strength of Windsor chairs. To do this joint, we're going to be using a tapered reamer. To proceed, we're going to have to make the first of several paradigm shifts. In making a chair, a paradigm shift means that at one stage in making the chair, you're thinking in a certain way. Then, as you move onward, you have to change the way in which you're thinking. Last step, we drilled these holes, these 6-through holes. And in doing so, we used a single bevel square with a sight line. We're now going to be working with 2 bevel squares. We're going to break the individual angles of the chair out into numbers of degrees, and we will be working with rake and splay. Now, there are 4 angles involved. 2 of splay, front splay, rear splay, 2 of rake, front rake, rear rake. They are not all equal in importance in the chair. So what we're going to do is arrange them in a hierarchy, descending order of importance. The first job, the job we're going to focus most attention on, is our front splay. We want to get each leg at 14 degrees of splay. Why? Because the front legs are symmetrical. If they are in the chair like this, it's obvious to anyone looking at the chair. So for the sake of the chair's appearance, we want to achieve 14 degrees of splay in each of the 2 front legs. Job 2 will be to get the front legs, the front rake angles, in a narrow range, but coplanar. And that's the operative concept here. They need to be coplanar somewhere around 10 degrees. There's a little bit of latitude here. Why? Because if the legs are at 10 degrees or 9 degrees or 10 degrees, nobody can see that. But if the legs are not coplanar, it becomes very obvious. After that, we will make our second paradigm shift. The second paradigm shift is that when it comes to the rear legs, there are no angles. What do you mean? You look at the chair, obviously that leg is in there at an angle. It has an angle of both rake and splay. True, but we don't know what they are because we're not focused on a set number of degrees. We will focus instead on getting this distance on both sides of the chair the same. If it's just simple geometry, if this angle is the same on both sides, you measure down the same distance, you measure back the same distance, these 2 angles will be the same. We will accomplish rake angles the same on both sides of the chair, but we won't do it by focusing on the number of degrees, but instead focusing on this distance. And then job 4 is the rear splay. We eyeball that to get symmetry. So if they're slightly off, that's fine because that's the least important in the hierarchy of angles. So it's front splay, front rake, rear splay. The tool we're going to use to ream these holes is a tapered reamer. It has a sharp scraping surface right here, so when you mount it in your cordless, you do want to be careful. Don't be holding on to it when it starts to turn. That's the safe way to put your reamer into the cordless. Now, our front splay angle is 14 degrees. You can get these, the angle is listed for you on the dimension sheet. (14 degrees), and then the rake is 10 degrees. Now observe something important. I'm working with 2 bevel squares. The risk anytime you have 2 bevel squares is confusing them. To avoid confusion, my bevel squares don't look anything alike. This one is large, has a dark handle. This one has a shorter blade and a lighter colored handle. I can distinguish them at a glance. A working habit, my working habit, and one I recommend for you, is that you choose a bevel square and you use it in every chair you make for the same purpose. This is my front leg bevel square. It is my splay bevel square. This one I always use for rake. If I were to pick up the wrong bevel square by accident and start to work, my working habit would set an alarm bell off in my head and tell me, you've got the wrong bevel square in your hand. So anytime you're working with 2 bevel squares, find some way to distinguish them. If they both look alike, put some tape on them, do something that will distinguish one bevel square from the other, and always use the same bevel square for the same purpose in a chair. Through the reaming process, we're going to use this device here called a Van Hovenometer. Its purpose is to provide me a straight edge against which I can measure with my bevel square. The problem with measuring against the leg is it's irregular and it's hard to achieve accuracy. The other feature on the Van Hovenometer is it has a 9/16 shaft which fits very nicely into a 9/16 hole. So now I have the Van Hovenometer in the chair at the angle of that hole. And I will use it to determine just how accurate I am, so that when I ream with the reamer, if I have to make any corrections, I can do that. I can begin to make those corrections with my very first attempt. Now, splay has a very precise definition. It is at a right angle of variation from the center plane. So when I put my bevel square in place, I want to be sure that I established that relationship, because you can see I can get all kinds of angles otherwise. So I will point the bevel square handle at the other hole, right angle to that center line. Now that I've established this and I look down, I can see I have a slight gap up here. What that indicates is that I'm slightly under 14 degrees. My leg, and in reaming, will have to go that way. Now I'm going to check my front rake. Again, rake has a very precise definition. I cannot measure with accuracy unless the handle of the bevel square is parallel to the center line. Splay at a right angle to it, this one parallel to it. And it looks like I'm pretty much dead on with my rake. That means that when I ream, I'm going to want to maintain this angle, but make a slight adjustment this way. The reamer has a pilot on the end of it. I put the reamer in, and that sets me up at the angle that the Van Hovenometer was just at. And so now I know that I need to move or pull the reamer and the cordless a little bit that way. Not a whole lot, just a little bit. There we go. Now, the question that just went through your mind is, how did he know how deep to go? So I'm not focusing on how deep. I'm instead focusing on how high I am projecting, the tenon is projecting above the seat. There is no predetermined amount. What I'm trying to accomplish is, to the extent possible, getting the same amount of projection on either side. So one front leg projects, as to the extent possible, the same as the other front leg. The reason being that if I get a great deal of difference in my amount of projection, I risk this in my stretcher and the stretcher going out of plane. Rear legs, I want them to project, to the extent possible, the same on both sides. I don't care about front to back. They can be different. There can be a great deal of difference front to back. It doesn't matter, because the stretcher will remain planar and we can adjust for this in the chair. The operative word in this process is to the extent possible. Mercifully, the problem of the stretcher going out of plane, takes a whole lot of difference. So we can be off a bit and not create a problem in the chair. There is no set amount of projection, but there is a minimum. The minimum is I have to be able to catch my thumbnail on the edge of the tenon. If I can do that, that's sufficient. On the other hand, if I get 1.5 inches of projection, that's fine too, as long as it's very similar, about the same amount on the other side. When I put the leg in place, I haven't even broken through the surface yet, so I've still got lots of room to go. I check again, once again, with the Van Hovenometer. And even though I made a correction, I didn't get enough. I'm going to still have to increase my angle of splay. My angle of rake remains fine. Now, to make that adjustment, I put the reamer in place, I put some weight on it, and I'm now in the same position, the same location as the Van Hovenometer. And I will move to this direction in order to pick up the correction that I need to make. That did it. I'm at 14 degrees. I check again my rake. It has remained dead on. And the leg projects through sufficient to catch it on the low. It's about 3/16 of an inch. So that leg is set and done. We're now ready to move on to the next leg. But before we do, let's talk about a problem that results in making corrections. Okay, here is how we correct the hole. If the hole has, in this case, let's say, too little splay, we're going to have to pull the reamer in that direction. Now, when we do, we change the axis, the center line of the hole, but look what we've done. We've made the hole into an oval, and we've lost its ability to self-lock. So, the second step in correcting a hole, after having pulled it to where we, to make the correction, we have to push inward and make the hole round again. But look at the problem that that creates. Suddenly the hole gets very big, and we can run into the problem of over-reaming. So the secret with reaming is to be very gentle, small amounts. So our first hole is set. We're moving on to the second. Again, I put the Van Hovenometer in place, and I check my angles so that I know what I need to do in order to make any corrections right off the bat. And I'm consistent. I'm just slightly less splay than necessary. I need to increase my splay slightly on this hole. And I check my rake angle, and I don't have sufficient rake. So when I make my corrections, I'm going to increase splay slightly and rake at the same time. So instead of moving in two different planes, I'm instead going to lift the reamer at about 2 o'clock. Well, I overcorrected, I have slightly too much splay now. So my next turn with the reamer, I have to pull the angle in slightly, the splay angle. I have to decrease it. Now, this is the problem. When we set up our hierarchy, the front legs were 14 degrees of splay, but we established that the front legs only need to be in a range around 10 degrees. Let's assume that this leg is 9 degrees. That's a perfectly good angle. This one's 11 degrees. That's a perfectly good angle. But the problem is they're cattywampus. So I can't use the bevel square anymore to measure rake. I'm going to use another technique. Now, that's the only safe bevel square. When you're done with the bevel square, collapse it, because if it's collapsed, you can't pick it up by mistake and confuse yourself. To measure rake, we're going to use a pair of winding sticks. This is simply aluminum channel. You can purchase an 8-foot strip at a local hardware store or at a Home Depot. I cut them to 2 feet long, and I sprayed one black for contrast. We'll use them as winding sticks. We place one down here, and we place the other out on the end of the legs. And I did this just to see how much adjustment I had to make on this side. And there we go. Now, as I sight down them, I see that this leg here has slightly less rake than is necessary. So when I make my corrections, I want to decrease my splay, increase my rake. So the bevel square and the winding stick have told me that I need to increase rake slightly and decrease splay slightly. So I'm going to make my correction at about 10 o'clock. Notice, there we go, we're dead on with splay. Notice how little I take when I ream. If when you're reaming, you're going, you have the wrong concept. It's very small amounts to make your adjustments. Once again, I'll check with the winding sticks. And they're pretty much dead on. Problem is, I don't have sufficient projection here. I'm going to have to ream some more, which I hate to do because every time you ream, you risk moving or losing your adjustment. I put it back in. I put pressure on it so that it locks into position. There we go. There we go. And that's perfectly acceptable. So now my front legs are done. Before we move on, a cautionary word about winding sticks. Winding sticks are like a micrometer. They'll detect the slightest variation. They're more sensitive than you need to be. If you are seeing half the surface of the black winding stick projecting above or below the lighter color winding stick, you've detected half a degree. So the concept here is don't get carried away with trying to obtain exact precision with your winding sticks. They're more precise than you need to be. Two front legs are done. We're now going to focus on the back legs. And once again, we have to remember the paradigm shift. When it comes to the rear legs, there are no angles. We accomplish the angles of the rear legs through comparison. And we can't compare them if we do them one at a time. So we're doing the two rear legs at the same time. We're going to ream both these holes and then set the chair up on its four legs. By the way, notice what I just did. I've been reaming like this. If you flip it over to ream these rear leg holes and grip it the same way, you'll crush the pommel. So instead, I'll use the vise to grip the platform. No rear leg angles. We're going to establish the rake angles and make them the same on both sides by measuring between the legs and getting this distance the same on both sides. it'll be self-evident where I'm measuring from if you think about what our end purpose is. That is to get stretchers of the same length. And so I will measure from this point on that scribe line to that point on this scribe line between the legs. And the way I do that is I take and I pinch the tape measure against there, extend it back, and I rotate it so I can read it. And I look across like that. I'm getting 12 3/4 inches. And I'm getting 12 3/4 inches too on this side. Now, if you look, this dimension we will be referring to as X. We're calling it X because it's variable. If you look at your dimension sheet, it says X equals 12 1/4. 12 1/4 is a typical number. It means that if I make 100 sackback Windsor chairs and I plot them all on a bell curve, at the top of the curve will be 12 1/4. The other numbers on the curve are valid. They just are not as common as 12 1/4. That said, there is a minimum and there is a maximum. And again, this is on your dimension sheet. I don't want this dimension to be less than 12 inches. If it's less than 12 inches, it means that the end of this leg has moved too much this way, making the chair tippy and putting the sitter at risk. I don't want this dimension to exceed 13 inches because if I get over 13 inches, the weight of the sitter coming down into the chair no longer goes down the shaft of the leg. Instead, it fulcrums on the leg and weakens the joint. So there's a minimum and a maximum. No less than 12, no greater than 13. 12 3/4, perfectly good numbers. They just happen to be not as common as 12 1/4. Now, there is some tolerance built into this, and the difference can be 1/8 of an inch. So if this was 12 3/4 on one side and 12 1/2 on the other side, that's too great a difference. If it were 12 3/4 on this side and 12 5/8 on the other side, I can live with that. So I have 1/8 of an inch of tolerance between the two, otherwise they have to be the same. Our fourth angle is our rear splay, which we'll accomplish through comparison. I've just taken and put the feet on the edge of the bench, so the edge of the bench becomes a straight edge. And I'll take and put a winding stick against each leg. And I'll measure the angle on one side and compare it to the angle on the other side. It's almost dead on. But if it were not, if one is slightly off over the other, that's acceptable because we're eyeballing the rear legs. I would accept a difference of half a winding stick. So all of this has told me that I have a good result that I can live with. But I have one problem, and that is this leg does not project through above the surface. I'm going to have to go back and ream it so it projects about the same as this one here. One last thing before we finish. I'm going to take the number, my number here, and I'm going to write it on my seat. X equals 12 3/4. And the reason I do that is I'm going to need that number in the next step, and if I have it here, I won't forget it. Thank you for watching this content. I hope you enjoyed it. Be sure to like, comment, and subscribe to this channel. And check back frequently for more Windsor chair making tips and tutorials.